Hello and welcome to this tutorial series where I'll show you how to create a procedural shader in Houdini Solaris using MaterialX. In this part, we'll go over the basic setup for a procedural tile shader. We will set up our scene, create a shader to control tiling, change the size of the grout between the tiles, add color, and set up displacement. So let's get started. For the first step, we'll set up some geometry. I'll make a grid node and dive inside. To calculate the UVs, we'll use a UV texture node. And I'll finish this with the output node. Now, back at the stage, we need to make a material library to start creating our tile shader. I'll set the display flag to the library. I'll also turn on the assign geometry checkbox and give it the path to my geometry. Now, inside the material library, let's create the MaterialX builder node and rename it to tile material. Now we'll dive inside the builder node and start our procedural shader setup. I'll put down the texture coordinate node to get access to the UVs. Let's visualize this by connecting it to the base color input of the surface node. We'll create a UV tiling setup next. The UVs are in a 0 to 1 space. If we multiply it by a value larger than 1, then that value will control the amount of tiling we have. So I'll put down a multiply, connect it in, and a constant node. I'll set the constant signature to vector 2 and the values to 3 and 6 to get rectangular tiles. Now in the U-axis, the value goes from 0 to 3, while it goes from 0 to 6 for the V-axis. But to create tiles, we need to have 3 tiles of 0 to 1 in the U-axis and 6 tiles of 0 to 1 space in the V-axis. That can be achieved by using a Modulo node, since the Modulo function returns the remainder of the division of its inputs. To understand this better, we can visualize this with an example. Here we have a line between the points 0, 0 and 10, 10, with a bunch of points along the line. If we run a modulo function on this, all the values up to 1 are going to be returned, but it will fall to 0 as soon as it hits 1. This repeats for all the points. Okay, back to the shader setup. Next, let's create a grid pattern using these UVs to make our tiles. Let's understand what we're trying to achieve and how we're going to achieve it. We need to create a line at the boundary of each UV tile. We know each UV tile is a 0 to 1 space, so if we can retain the 0 value, but push all the other values to 1, we will have achieved what we need. So let's try implementing that. We need to first separate the components of the UV vector. I'll use the separate to node for that. Next, we'll put down the floor node and connect it in. The floor function takes an input, a real number, let's say 3.7, and returns the greatest integer that is less than or equal to the input. In this case, that will be 3. So for our UV, the floor node will return 0 since the UV coordinates have a maximum value of 1. The greatest integer that is less than it is going to be 0. But we can multiply the UVs with a number greater than 1 to push it beyond the 0 to 1 range, and then the floor node will start to return a usable result. So let's put down a multiply before the separate. Let's set the value of this multiply to something like 50. And we see we are getting some output from the floor node that is not 0. The resulting output has a range of values, but we are interested in just 0 and 1. So using a sign node, which is a derivative of an absolute value node, we can get that result we need. The sign function returns 1 for all positive values, -1 for all negative values, and 0 for any 0 values. Let's do the same for the V coordinate by copying this setup. Using the min node, we can find the minimum values between these two outputs, and we can see that we are getting the grid-like pattern. However, the grid lines are not of uniform thickness. The thickness is different on each axis. We can fix this by changing the values on the multiply we put down before the separate node. The ratio between the line width for each axis should be reverse of the ratio used for tiling. The tiling ratio is 1:2 in our case, 3 tiles in the U, 6 in the V. So the reverse would be 2:1, which we need to use as the line width. We can do this procedurally by separating the components of the tiling constant, then combining it back with a combined vector 2 node, but switching the U and V coordinates around. Before plugging this in, I'll multiply it with a constant so the line width can be controlled by a single value. I'll name this constant as line width instead. But we run into a new problem now. As we change the width, we can see it slides only from one side of the grid. The width is not changing from the center of the line. We can fix this by copying all the nodes after the modulo. Then we need to insert a subtract node to invert the UV coordinates. We will subtract the UVs from a value of 1. Finally, using a min node to combine the outputs of both these chains. Now, changing the line width behaves as we would expect it to. We can put down a clamp at the end to get rid of any values below 0 or above 1. Let's use this black and white grid as a mask to give these tiles some color. I'll put down a mix node and plug the clamp into the mix input. We can set the signature to color and give some FG and BG color. I'll also connect the output of the clamp to the displacement input to displace our tiles. And let's set the scale to 0.1. That's the basic setup for our procedural tile shader. In the next part, we will go over how to create a staggered tile pattern where every other row of tiles will be shifted. We will also introduce some warp to the tiles, create a bump map, create a taper on the edges of the tiles, and more. Thanks for watching, and I'll see you in the next part.